before I dig deep into the blast gates thing, is there anything that people that anybody has they want to talk about or show things they've done in design, whether in Fusion 360 or OpenCAD or SketchUp or any of the other packages, or any questions or problems that people have they'd like to discuss in a group setting?
I can show you the cup holder.
Yeah, that'd be great.
Fusion 360 or FreeCAD. Ceiling. Somebody's in their RV. Todd.
Yeah.
Todd's in his trailer.
I am. What was your first clue?
Well, for some reason you've got the main view, and I can see your lights, and I know those lights.
That's right.
So let's see. Should I share my screen, maybe? Share screen. So there, yeah. You see that?
Yep.
What the dickens is that?
That is, you can still see me down here. This is a cup holder. You know Jack Murphy Stadium?
Okay.
It was tore down, and I've got a friend who's another Aztecer, and he had season passes, and he bought some of the chairs. So you can buy some of the seats. Before they tore it down, you could buy some seats. So he bought them, and they basically only gave you one armrest. And I just thought, I saw that, and I was like, well, that's cool, but you can't have a buddy sitting there drinking with you. So I said, well, let me see if I could make one of these. So I don't know, sometimes I look for things that force me to make stuff. So I went ahead in FreeCAD and CAD'd it up. And it's going to be interesting to see how it prints. I'm going to try to print it without supports under this thing, because sometimes it's tough to get supports out in the 3D print. But it was basically, and there's so many different ways you can make these darn things. I mean, that's why I always like watching the techniques that Tim does for how you do it. So like I made this cup holder part first as an assembly, making basically a few cylinders, boolean them together, and then basically made a copy of that, scaled it down, and did a Boolean subtraction to basically hollow it out, and then just added this piece to the bottom. Because that's exactly, I'm trying to make it as close to, the way it was. So that ended up being one piece, but I could have, another way you can do it is basically do a side profile and then do a circular path, because it's got, cup holders, so you got the different sizes in there. But that's the thing I always, I like watching people now. I like watching how other people do things, because there's so many different ways to get the same job done. And sometimes you find out that, oh yeah, that's too hard. Throw it away. Let me do it this other way. And it's go, oh yeah, that was easy. Because this thing here, I did a lot of fillets on here to smooth it out. Well, when you go ahead and do a profile, you build the fillets into the profile. there's no fillets to do after the fact. You basically can make everything as smooth as you want. So that might be how I would do it differently, is that. And then I ended up making this as, this was basically extruded. Geez, how did I do that? I forgot how I extruded this to get this 2 different sizes. It was kind of like along, I forget how I did it. But anyway, somehow I forget the technique that I used, because if you can see that this is a different size, it's, you know, it's bigger here than it is here. But I remember I did a profile, because it also has this profile where it's wider at the bottom. So this was a sketch that I then extruded, and I forget, there's like an extrude and an expand or something.
Well, you can generally add an angle as you extrude.
Yeah.
So
that was something. I mean, most of the stuff that I've seen in Fusion 360, I've seen in FreeCAD.
right.
That was what was so amazing, and how easy it was for me to switch over. Just that their names are a little different, but the techniques are all, you know, standard. But the thing I ended up doing was I made this kind of like one part. I made this one part, and then I made these pieces, and these supports, all part of another element that then I booleaned all back together.
Yep. Cool.
So I haven't fitted it yet. The original is like a hack. I'm going to show you through the small picture, but the original is like a hack. You can see where they took some sort of saw and ground things out. So kind of weird. So I'm hoping that, I mean, I can't, one way or another, I can get this so that it'll fit on his armrest, even if he has to add a little bit of adhesive to it or something.
Yeah.
So Doug, why are you using FreeCAD rather than Fusion?
Well, when I first started using Fusion, and Tim, I learned everything that here I learned from what Tim showed. So I used Fusion, and then I hit a hiccup. I did another project, and I had a hiccup. I couldn't figure out the technique, and so this is maybe 2 months after I started. So I shared the file with Tim, and he went ahead and sent the file. He said, "Oh, if you do this, then that'll work." So he sent me back a version of the file that he had manipulated, and I couldn't load it. And it was telling me that I had to update my software. And I looked at the version that it was asking me to update to, and I looked at the version I had, and it was version like, it was point, XX. It was like a insignificant digit change, but the file formats were completely different. You couldn't load it. So that's because they're web-based and they want you to keep updating, so they don't worry about file system compatibility. I've been through this with Microsoft and Lotus and all those back in the 80s and 90s. So I was like, oh man. So I went to do an update, and I found out that they had changed. I don't run Windows, but I can generally run Windows software on Linux. But they had done something to Fusion so that if I had run the update, it would have not worked. So that was one thing that got me. That was like, oh crap, they're playing file format change, stuff to keep you chasing along. And then they announced that they were changing their licensing. They were going to drop STL export. They changed part of their G code stuff. And that just pissed me off. I'm just like, okay.
But none of
And I
that
saw,
happened though. The STL export you can still do.
Yeah,
well, yeah, they
backed-
changed their tune. They changed after enough people complained. They went ahead and backed off on it.
Yeah.
But during that 1 week period where all this commotion, and I'm on a number of forums, so there are lots of conversations about this. And I ran across a couple of people who said, yeah, I switched to FreeCAD last year. Or yeah, I switched a couple months ago. So I'm like, I emailed them and said, I tried FreeCAD like 2 or 3 years ago and it wasn't working well for me and stuff. They said, no, a year ago, the 2.9, the 2.9 version or the 2.29 version or something like that, way better, works fine. And so I went in and I did a little test on it and I'm like, holy cow. Yeah, this was, it was an easy switch. So it doesn't have the cool, I love on Fusion, that neat little history ticker at the bottom. But I didn't use it enough to memorize all the keys. Had I been a guy that, like Tim, who memorizes keys or stuff, it's tougher to switch when you have that memory because you can do things a lot faster. I haven't got that memory. So it was pretty easy. I can find all the different things to do. It exports. It does G code if you want it to. Exports umpteen number of different formats. And,
Yeah, no, it's, I've said all along that, any of these CAD packages, you find the one that works for you. And what we're trying to, we started out focused on Fusion 360, but we really want to be a design SIG and talk about different things you can do. I'm continuing to learn Fusion 360. I have frustrations with it. I've kind of come the other direction. I've come from high-end engineering, 3D CAD, and so I get frustrated with the things Fusion 360 can't do. But I do manage to make it eventually do most of what I need. And so one of the things, the last 2 weeks we talked about the desk projects. We had 2 different designs. We had one which was more of a traditional carpentry design. And then we switched to, and we built one of those, and we have a build of 10 coming up, I believe on the 18th. Unfortunately, I'm not going to be available for that, but Kurt is going to lead that build. And then we had a design that Perry put forward, and it's basically a CNC design. We added some laser cut boxes to it. So it's a combination of the laser and the CNC router. And he's built one proto, and I think maybe we'll look at a few more of those. We've tweaked the design, made it parametric, and also sized it and panelized it so it can be done on the XXL in the shop. But the project we started looking at most recently was automating the blast gates for the dust collection system at the shop. And, Dallas might be able to give us a little bit of history there, but we started some time ago and looked at a couple different designs. I'm not totally sure of all the history behind the make-buy decisions, except that we are makers after all, so why would we buy something we can make? And I'm sure some of it was economic and also sizes. I noticed that there's one, is it called Ivar or something of that nature? And they have a 4 and a 6 inch gate, and we're using 5-inch system. So, that's one reason perhaps.
so
And-
5-inch because all the hoses are 5-inch.
Right.
Okay.
Right. So, and that might be possible to change too. But meanwhile, Jerry and Dallas looked at a couple different approaches, and so if you're familiar with the blast gate, it's just basically this metal gate that you open to allow the airflow and the dust collection system, and close to preserve the vacuum in the system so that other machines can use it. And most people just use a manual one, and if you're used to using one, it works great. If, like me, you're not really used to it, then half the time you forget to open it, and the other half you forget to close it. So the idea for the shop was to automate it and use current detector to tell when the tool is on, and use that to trigger a relay to open the gate, and then again to close it when we're done. And the key, one of the key elements, where did I put that? One of the key elements, well, I'll show the finished unit here. One of the key elements for the motion here is an actuator. It's a linear actuator. So basically inside there's a lead screw with a metal and plastic nut that goes on a carriage. So the actuator mounts here, and this carriage can move back and forth. And when it moves back and forth, we have it connected to the gate, and it opens and closes the gate. After some time, we saw some failure, and so kind of looked at, was it electrical, was it mechanical, and I think the idea was that let's have a look at mechanical and see if there's something there. And there were a couple of possibilities. I'm not entirely convinced that we've resolved it, but I think there's a pretty good chance. In one case, on the carriage, on the original design, the carriage had an offset bracket that then moved the gate. And that could put a little bit of twist on that carriage and on the lead screw. And I'm not sure that this little actuator was really designed for that. The linear actuators usually like a straight linear or axial force. So looked at making that change. And then today as well, I started to look at how the gate closes. And one of the things I noticed with the original metal gate, the gate shape has a bevel to it. So the top of the gate has a bevel that looks kind of like this. This is an acrylic version. But these corners could catch up, because one of the things, some of the systems we saw, people, particularly if it was one machine system, they would open the gate before turning on the vacuum. In our shop, that's not practical. So you're doing it under load. So the vacuum is actually pulling on the gate and causing some friction inside the mechanism. And with those corners, can't see you there. With those corners, what I'm finding is that these corners could catch as it entered the round part of the gate, of the housing of the gate. And depending how far it catches, it could completely jam. And if it jams, then the motor stalls, and these are permanent magnet DC motors, and a couple seconds after stalling, they burn up.
So was this because the receiving slot was so narrow that it could hit?
It's actually pretty wide. It's pretty wide. The gates, have a little bit of play in there, but
Right.
they can get damaged. They can bend. All it takes is to catch on an edge.
Right. If they have if the slot across the top and the bottom and the end were all the same size, then yeah, there's no extra. But if the slot at the end was a little bit wider, then it wouldn't be able to actually catch. It would hit, on the top. It would run across the slide as it gets sucked in. It would slide, but the end couldn't catch on anything.
Hey,
That
Doug,
would be the idea, but
Yeah.
keep in mind that you have a vacuum force on there, which is like a pressure, and this gate can actually bend a bit.
So, oh yeah,
And the
Yeah,
corners
that's-
catch.
that's
Doug,
flexing.
The other thing we think happened is some debris may have hit it and caused it to be bent a little bit.
Yeah.
So
And
can I ask you a question?
sure.
The way this operates is a person goes and turns on the dust collection system, then goes over and opens the gate. Is that the way it works?
Basically, we turn the dust collection on in the shop at the beginning of the shift. So the dust collection is pretty much running anytime any of the machines are running, but there's 4, 5, 6, 7 different machines at a time
I
that
see.
can be running. And we only want the gates open to the ones that are active. Otherwise, there's not enough vacuum to draw the dust in at the machine that's in use. So the idea is to use these to keep the gates closed on the machines that aren't in use and open on the ones that are in use so that you get proper airflow and dust collection.
I see.
Yeah, so, and then one other possibility for why the motor might have failed is if we look at the actuator itself, there's not a lot of free space between the stops at the end and the carriage and things like that. And if you get some crud building up in there, you could get a case in which it hasn't reached its limits, its electrical limit, but something mechanically blocks it, and then it could fail.
It kind of starts binding before the switch
Correct.
gets triggered.
So the brainstorming ideas that we've had so far have been to try and first of all, on the mechanical system, change the assembly such that we load the actuator in a balanced axial fashion. And I made a change to this gate to change the shape, and I'll show that in CAD in a little bit. And then the other idea we've had is if we had an Arduino whiz somewhere, instead of using the simple logic and relays that we're currently using, we could use an Arduino to control it, and the Arduino could just monitor the current continuously, and if the current exceeds a limit, could then cut power before the motor burns up.
As well as Bronx and Carlo. So why wouldn't the former?
Yeah, you almost might use something like the ESP8266 that has Wi-Fi on it. Or you could use the Arduino, but you'd want to have like an LED or something to indicate that the motor's jamming,
Right.
right? 'Cause that's what you're trying to look for is when the motor jams.
Well, and Dallas
don't
was
burn it
also
out.
suggesting a few other things to do with the Arduino. Dallas, you want to
Sure. I
elaborate on
think there's
that?
a lot of other possibilities with having the Arduino there. I'd like to have some information on runtime on the machines and number of cycles that we have, for blade replacement, maintenance purposes. We can also use it to garner some maintenance information if we were to monitor the current on the load on the machine to see if we are having any overcurrent situations and so forth. But really, I'd like to have that cycle and runtime just for maintenance purposes.
Dallas
yeah,
is going
you
to
know,
plug
that's
this
right.
into the
Have a
artificial
Wi-Fi
intelligence. Dallas is going to plug this into his artificial intelligence system to do preventative maintenance, right?
Well, actually, I've got a little system at home that's running on an Arduino, and I do keep track of that. But I start my machine, and mine doesn't have near the cycle time. And I'm just using the commercial blast gates, the IVAC systems, the 4-inch ones.
Yeah, 4-inch IVAC system. At any rate, what I thought I could do with this is, having kind of gone through this, maybe I'll go through the steps to capture this. First, I'll show you the end result, and then I'll go through the steps of how I went about doing this. And people have questions, suggestions. And, as Doug mentioned earlier, there's multiple ways to do things. And I often learn from other people as well. Even people who don't have that much experience just take a different approach. And that's happened with this SIG in several ways. People have surprised me with what they've done. It's been more efficient and useful, and they've done things that I didn't even think of doing on Fusion 360.
Because obviously they're calling your
So
birth.
let me just,
Hey, Todd?
Yeah.
Would you mind putting yours on mute? We got some other background noise. You cut into the rest of the presentation sometimes.
Really? I don't know what's going on here. I'm not making any noise.
I could hear like a radio or something in the back. There we go. Thank you.
okay, let's see here. Why is Fusion 360 acting up on me? The active screen going here. Just bear with me here a second. I apologize. But Fusion 360 doesn't seem to want to cooperate properly for me. I'm just going to, oh, there we go. That's because it was behind the main screen. So let me just open it up and then share the screen. And we'll show you the design. Okay. Okay, are you able to see that?
Yep.
Okay, good. Now let's see if I can get Zoom back. Oh, I guess I need to. So there we go. Change sides on things here. Okay, so basically what we've got here is started out by importing a gate from McMaster-Carr. And those of you who have seen this before know the routine on how you bring something in from McMaster-Carr. We go to insert in Fusion 360, insert a McMaster-Carr component. Now there's other manufacturing parts and they've added trace parts, supplier components, a whole lot of different things, a whole lot of different CAD models that you can download. I like McMaster-Carr particularly for fasteners and things because I'll do the design and then when I'm done, I'll order them and the next day somebody drops them off in my house. It's awesome. But you can say insert a McMaster-Carr component and then a little window pops up that just looks like their calendar. You can go in, do a search. In this case, we say blast gate and it brings up the blast gates and we choose whichever one we're interested in. So we have the 5-inch galvanized steel slide, and in the product detail, we pick step and then download, and it drops right into the screen, and we place it. And I'll do that a bit later with some fasteners. But that's how I ended up getting in this gate, and I've hidden the original steel gate here because I'm created an acrylic gate of my own for the time being. Now, the next thing I did, Dallas had actually done this and told me how he did it. So I just followed his lead and I created a new component. And in Fusion 360, you hit create new component, creates a new component in your assembly, and created a sketch. And you can always, when you create this sketch here, let me just kind of do that one for sake of showing people, is you can come in and grab an existing surface on a part and project it onto your sketch. And then you can add elements to your sketch as well, and you can cut it. So that's what I did here. I originally captured this surface and then put a line here to stop the part from going all the way around, save a little bit of plastic, and added a piece out here to make that gate bigger. And then when you finish sketch and extrude, basically, and let's just go back in the timeline to that point. Then I ended up with something that looked like this. And Doug mentioned earlier adding fillets in profile. So you can add these fillets in your sketch, but I always kind of prefer to add them in as a separate feature because then I can find them and change them quickly. So I put some rounds there. Here I linked in, the next thing I did was linked in the actuator itself and put it in an approximate location. I actually end up moving it later. So this,
Tim,
yes,
the cool thing about the way you did that is that you get the exact hole locations in the sketch, which is perfect. But the other thing, the thing that gets me is that you also have the profile of the tube holder, and that, did you have to adjust that so you had some clearance, or did you? I mean, because that's almost like going to be too perfect, too tight.
yeah. So a couple of things. You hit 2 points. One you intended to, and one you didn't intend to.
Okay.
But it's really they're key points. So you know, Dallas had said to me, "Well, you go to McMaster Car, you can grab the gate." Well, I went to McMaster Car and I grabbed the gate. Turns out it wasn't the exact right one. So make sure when you do this that you grab the right one. That's point number one. The second is, yeah, when you look at an area like this, this area in here is too tight to
Right.
this because it's line to line. So you often want to put in a clearance. And so in fact, I ended up doing that here later on in this part design. So here I added slots. You'll see that the slots are for a bracket that connects between the actuator and the gate. And then I cleaned up some things with some fillets. I first just made rectangles and slots and then rounded them. Or you can use the slot feature. There's numerous different ways to do these. But let's see, what's this one here? So this one here, what happened here is once I realized, oh no, this is where I drilled a hole again using the basically projecting this hole down onto the plastic, or at least using the center of it. In this case, I used the center of it because the original hole is too small. You actually have to drill these out because we're using 1024 here. So I used 1024 over here. And the hole, this actuator is metric, and the hole was only, I think, 4¼ millimeters. So it was too small. So it has to be drilled out. But what I ended up doing here, it was two things. One is when I realized I had the wrong gate and I couldn't find a model for the correct gate, what I did is, in case somebody wanted to use this design with the gate I used or the other gate, I changed some of the holes to slots because there were just tiny differences in the dimensions. And while I was at it, I used an offset line in Sketch to offset this arc to give clearance around there per Doug's comment there. So once you have a plate like this, there's a couple of interesting things you can do with it once it's done. And I cut it with the laser table at the shop. And here's how I typically go about doing that. I grab the part I want to do. I hit isolate, so it hides everything else. Now I have my part. And in order to get what I really want from here is a DXF file that I can take into Lightburn to cut with the laser. So I'll just create a fake sketch, and I'll grab this surface, and then I'll do a project, which is the letter P, or create, is it create, project include, project, and grab this surface. Now it creates a sketch that has all the edges normal to this surface. And I will finish sketch, and then under the sketches, under the part and under its sketches is this last sketch we just made. And if you right click on it, it'll say save as DXF. And that's the quickest and easiest way to get a nice simple DXF like that. You can also create a drawing and export a DXF from the drawing, but I find this quicker. So that's what I did. Cut this part out and away we went.
Okay. There's no way just to project the actual design, the model itself, that part, just do a projection and then export. You have to actually go ahead and make a sketch.
Yeah, I did it in a sketch, or you could do it in a drawing.
Okay.
But I'm not aware of a way to just like project a view or something like that.
Yeah, I think in FreeCAD and in OpenSCAD, there's a way to actually just project your model, and you can project it from different elevations, and that gives you a 2D part that then becomes exportable.
Yeah, no, the export,
Easy enough.
I'm just checking the export. The export doesn't do that. Yeah. And then when I'm done, I usually just delete that sketch because I don't need it for anything else.
Yeah, and as you get more familiar, it becomes so easy to do this. It's
Yeah.
a 2-minute deal, so yeah.
It's really a 30-second deal here. So for those who want to do planar parts in Fusion 360 and cut them out on the laser cutter, that's one way. Now the other thing you could do is CNC a part like this out. Why would you do CNC? Well, maybe you have a CNC and you don't have a laser. So, I've, over the pandemic, in order to play with learning some of these things, I bought a few toy machines. So I consider the Ortour a toy laser because I can't really cut much with it, but I can kind of engrave with it. I also got a 3018 CNC engraving tool, which is kind of like a baby router. And this part's too big actually for the footprint, but I did cut one of the gates in here using it just earlier today out of acrylic. But if you want to do this in CNC, that's possible as well. So I'm going to show you that procedure. So you go to the manufacturer option. And actually, I've done it once already. I'm just going to delete this and do it over so that everyone can see what the steps are. So first, create a setup, a new setup. And this just is setting up the machine, the workpiece, some things like that. So you can select a machine, and there's a generic 3-axis milling machine. This is also where you can select a 3D printer. I happen to use a resin printer, which isn't supported, but the FDM printers are. And I've created a custom machine for my little toy router. And so I can put tools in it and I can see what the envelope is and things like that. So once I do this, I've selected the machine, I've said milling. The next thing I need to detail is the coordinate system, and it starts out in the center, which doesn't really work for me in this particular part. In this case, I would rather have it be over here. And this orientation isn't what I want. I want X where Y is now, and I want Y in the minus X direction. So I'm going to go into orientation, select the Z-axis plane and the X-axis. So for Z-axis plane, I'm going to pick this top surface of the part. And for the X-axis direction, I'm going to grab this. Now I have the orientation I want. I'm going to go to my origin and pick a box point. Come on. And there's my origin is where I want it. Okay. Now I've got the orientation set up. The next thing to set up is the specifics of the work piece, the stock that I'm starting with. So if I have extra stock on the side, I can decide how much side stock we're talking about. Top stock, depending what I'm making. In this case, I'm cutting sheet material, so I actually don't want any top stock. And away we go. So there, I'm ready to go and define how to cut this piece now. There's an option here for post-process. Basically, there's not a whole lot here. You can give a program name and give it a comment. So we could say this is, oh wait, it's, yeah, mount plate, and comment is for glass gates. And I'm going to say okay. Now notice it's warning me. It says the workpiece maximum X is larger than supported for this machine. So if you've defined your machine, you'll get this kind of warning. I'm going to ignore the warning for now because I'm not actually going to make this part. I just want to show you how to do it. So now it sets this part is set up in manufacturing mode, and you can see the pale, the light colored outline is what the material would be that we would start out with, and the dark outline is our actual design part. So there are a number of different 2D and 3D drilling operations, etc. In this case, it's pretty clear. I'll just go over what some of them are. You can do clearing pockets. You can do a face, clean a face. 2D contour is what we're going to use. You can do a slot where you basically follow a line. You can do a trace where you trace along contours with varying Z values. And the nice thing about these is there's these pop-ups for everything. So it really helps you because I'll do it and I'll come back 3 weeks later and I don't remember what they all are. So in this case, I'm going to pick a 2D contour. And now it's asking me to pick a tool. So I'm going to select a tool, and I've defined the library, and it's pretty easy to define a library. You add a part and go through and add the information specifically to that library. And what I'm going to do in this case, I'm going to go to my local library that I've set up for the 3018 machine. And in some cases, I use the same tool with different definitions for different materials. Because I can define with this tool, I can define the feeds and speeds. So this case, I'm going to grab this one, 17, and it's going to pre-populate a lot of the values that I've defined in that tool. So I cheat a little bit. It's not just, like I say, one tool can appear in my tool bin multiple times when I want to use different speeds and feeds for different materials. I might want one for hardwood, one for softwood, one for acrylic, one for aluminum, etc. And I go through here and change the values. This thing moves really slow. It's tiny. It's like a, I don't know, 500 watt router or something ridiculous. It's kind of, I think it's a sewing machine motor, to be honest. But so I'm going 225 millimeters a minute, which is slow. And I'm cutting down 0.16 millimeters. So those of you who are in inches, that's 1/6 of an inch. But I pulled that feed and speed off a YouTube suggestion from somebody else. I really haven't taken the time to optimize the speed and feed myself yet. I'm still kind of playing with the machine. Different things, lead-ins, ramp, plunge rates, all these things we can edit. And then geometry, we pick our contour. So the first thing I'm going to do is the internal contours. So I'm going to grab these contours. I'm grabbing the bottom of the contour because that's how deep I want it to cut. And I'll go and grab all of these. I apologize with the black. I did the part in black because the acrylic I had was black. Makes it a little harder to see. And I zoom in and out a lot because sometimes it's a lot easier to pick your target at the appropriate zoom level. Okay, those are my 8 contours. And there's other things in here that we can use, tabs, things like that, that we're not using in this particular operation. Let's keep it simple. In terms of heights, it starts out with some default retract heights and feed heights. And with the limited tool, you don't want to go too high, but you want a safe height. If you're using hold downs, you want to make sure you clear hold downs. If you're using the tape and glue or a vacuum holder or something like that, or some kind of holding technique that's not protruding above your workpiece, then you can go a little tighter to it and speed things up a bit. But I'm going to leave these as they are for now. Passes, if you're doing multi-pass, which with the little routers we often are. So in this case, I'm going to say multiple depths, and I've got my maximum roughing depth at 0.15 millimeters, and I'm not doing any finish step downs because in this case, I'm just cutting through it. But you do have a lot of options to specify, and I'm not going to go into all of them right now because if you know CNC, then you'll be used to it, and if you don't know CNC, it's going to bore you anyways at the moment. So, but suffice it to say, those options are there, the options you're used to seeing in other CNC packages like VCarve. I find that I think it has actually more functionality than VCarve, although it presents it in a different way. And it's kind of generic milling. It's more anticipating traditional milling, whereas VCarve is kind of geared towards wood. When I've got that all specified, I say okay, and it creates my contour, and you can see it's calculating over here, and it has calculated now. And when I look in there, and let me zoom in on one of these, you can see it's cutting this oval 0.15 millimeters at a time. So there's 10 or 15 loops needed to cut each one of these. With a much stronger CNC machine, you might go through all this in one cut, or you might go through it in 2 or 3. But with the sewing machine as a router, sewing machine motor as a router, it takes a lot. That makes sense to everybody? Any interest? If there's a lot of interest in CNC at a later stage, maybe I'll go through in more detail. I think some of you have already figured this out on your own.
Yeah,
and then,
there's a lot of information. You can go to Carbide 3D and get import tool information into Fusion 360 and so forth. So for Carbide 3D machines, there's already a lot of info out there that you can use to instead of recreating the wheel, start further along the path.
so you've done a fair bit of machining from Fusion 360, right, Lem?
Yeah.
Yeah. So if you have simple questions, ask me. If you have complicated questions, ask Lem, please.
I don't know about that. Maybe pre-pandemic. I don't know about since then.
So, and then you notice that I picked those internal features with contour and it automatically picked the inside. And the same thing's going to happen if I do create a second contour and I have the same tool still selected. And this time when I go to pick geometry, I'm going to pick this bottom outer edge. And let me just make sure that my passes are still properly defined, multiple depths. No, somehow it's jumped back to the default of 1 millimeter. So I'll put in 1.5 and I'm going to say okay. And now it's crunching and calculating, and there it's done the same thing. And then when you zoom in, you can see it's got all these passes going around doing the outside. So I wanted to kind of cover several of the manufacturing options. I'm going to go back to design now, unless somebody has questions on the CNC machining or the laser cutting. I'm going to unisolate my part. And now it'll show me the other parts that, that we'd gotten to. And let's flip this over. Now I'm going to talk a little bit about the actual design rather than the CAD process. And what I did here, let me isolate this, but turn this on as well. So the original linear actuator, actually, let me turn this off. The original linear actuator model comes in like this. For some reason or other, they don't include the actual lead screw in the model, but from the manufacturer, I'm not sure why that is, but maybe just to keep it simple. And this part has a couple of interesting features and a couple of things we don't like. The wires aren't shown here, but the wires come out right here. And you can see them, I'll show them to you in the camera here. But the wires come out kind of between the motor housing and the carriage. So if that gets off to the side, it's going to pinch and potentially damage the wires. I get they put it there so that, because they don't know how you're going to mount it. Maybe I want to mount against this surface or the other surface. But once you've decided where it's going to go, I'm going to glue that sucker down so that it doesn't cause a problem. And to leave room for the wire, this carriage has a notch here on the one portion of it. And even putting a screw in here is a problem. I'm actually only using the 3 screws on the carriage. So in operation, this carriage slides back and forth. So just to show you that operation, so you know what I'm saying, let's go to slider. Hang on. Oh, I know. Why is that happening? Have the slider joint? I should be able to. Okay, let me just click on it right here. And for some reason or other, I guess I'm not far enough alive. Something is, let me just isolate, unisolate. Let's get everything. Now, is it going to let me, there we go. If I animate model here, you're going to see what happens. This carriage slides back and forth with the lead screw. And I've done that in the joint definition. That isn't using animate. That's just using the joint definition. You hit escape to stop that animation. And in this case, we're actually not even showing the carriage extension, which is the 3D part that we're using. So we need to connect between this moving carriage and the sliding gate. So the first part that does that is a bracket. And this bracket, Jerry had some extruded aluminum 1x2 tube. And so I just cut this piece out of there. And this is how I modeled it. So this is kind of a yoke approach. And it connects to what I'm calling the carriage extension. So the carriage extension mounts into the carriage with the screws that go through here. Let's turn this back on. So you can see that this carriage extension is designed to fit around the carriage. So again, I took a sketch off the front surface, projected the edge lines of the carriage, and used those as a foundation for the sketch, extruded it, and then added the other features, holes, fillets, etc. And move it back and forth. And then let's also turn on the 3mm screws that go through there and little lock nuts to go on top of them. Now we still don't have a connection between the yoke and the carriage. So this blue piece that I call the carriage extension is mounted to the carriage using these screws. And then what I did was I added these bolts as pins. And the idea here is that the axis of the pin passes through the axis of the lead screw so that there's no twisting forces, what a mechanical engineer will call a bending moment, or some people might call it torque, on the carriage of the lead screw. Because one of our theories was that bending moment could cause additional friction, maybe cause that carriage to jam. It also makes assembly a lot easier because you can just drop this thing on top. And then underneath, we have this plastic gate, and we connect it with a screw and a lock washer, and it can swivel a little bit so that it balances out forces again, so that none of the forces are causing a twisting moment on the linear actuator. So the forces are all nice and linear and in plane the way they should be. Now,
So when you replace the metal gate, what's the purpose of the acrylic?
well,
Reduce friction?
there's a couple reasons. The first reason was because the one I had originally had already kind of been used, and it had a big hole where I wanted a small hole. So it was easier for me to just cut one out of acrylic. And the second thought was I wanted to see how it would behave from a friction point of view. Now, I don't think there's much difference in friction because this is galvanized, so it's like a zinc plated steel, and that's pretty slippery stuff. I did notice, like I said, I did notice that it could catch on the inside edges. Now, the other thing that it would be a better gate design if there were a fillet on that inside edge so it wouldn't grab.
Mhm.
It would be potential to lose air maybe, but there's a big enough gap as is. So, you know, my first gate, I just mimicked this. But then what I did is I went to the design you see on the screen where I made this front oval so that it would, or an arc, so that it doesn't have those corners to grab. Because if I turn the gate back on, what was happening with the other gate was, let me animate model again, is those pointy corners up here, these pointy corners could catch right here inside the gate. And especially since vacuum is pulling down on it, or up, I guess it would be pulling in the most applications in the shop. And this gets away from one possible jam that we may have been seeing.
You might be able to grind down the metal ones to give you that round corner
Yeah,
there,
yeah,
too.
that's another possibility. We could either modify these or modify the inside of the gate. There's any number of places that you can put in some fillets or chamfers to reduce.
Or the end of the gate bevel where it grabs.
That's what I meant. Yeah, put a
Not,
fillet
well,
there.
not the actual gate, the gate itself. On
The housing.
gate itself. Bevel those corners where
Yeah, what
they
I did,
catch the edge.
I did that on the when I cut this piece with the rounded, which is
Yeah.
inside here. I just took it on the belt sander as well and beveled the edges to kind of get it in there. So basically what you were
Yeah.
saying.
Much
But-
easier than metal, but yeah.
It's the classic. Usually when you do things like this that are moving, you want lead-ins. And ideally, you want lead-ins on both sides. When you're making things that assemble, I come from a mass production background. When you're making things that assemble, you want everything to have lead-ins so that they fall into place better.
Yeah, what I saw in some of the other gates is they actually have a hole punched in a much longer metal sheet. And so there's constant contact the entire way, as this is only like half the thing, right? The
Correct.
other gates are like a big long gate with just a hole punched in it. So when you're pulling it out, you're actually just sliding a single piece of metal.
Those have
Always
the
in
advantage of
contact.
being self-cleaning as well.
There
And they
would
have the
be no
disadvantage of
place
being
for anything
longer.
to get in the. Yeah, there's always something in the slots down the sides.
Yeah.
So there's really never in here. You think about this when this is open, all that turbulence in that slot is going to drop little pieces of material in it, and that's what you're going to try to squeeze in,
Yeah.
So
Yeah, that's a good point. And that's what I mean. If you look at I mean, I saw it in McMaster Car, but any of the people who are selling blast gates, they have the self-cleaning ones, which are the design you're referring to.
okay.
The commercial ones I'm using, the IVAC ones for the 4-inch, are designed like that, where they just have a hole in the slot that goes all the way through.
Yeah.
Yeah, so I think that was a potential weak point in the initial approach that we didn't think of. But judging by what I see on the wear inside the gate housing, I think it's a realistic possibility.
So
How easy
on
would
the
it be
back
for
side
this?
of it. Go ahead.
Yeah, no, actually, in this case, you're right. What we could do in this case is all we need to change is this plastic piece.
Does it go all the way through?
Yeah,
Would
the
it go
slot
all the
goes
way
all the
through?
way through.
Yeah.
Yeah.
I don't think that's worth it. I don't see that as being a problem. These are considered self-cleaning blast gates too. There's nothing that causes the stuff to accumulate in the grooves because the suction through the port. If it is it does get in there, the gate's gonna push it out anyway. The slider push it out.
Yeah, 'cause what we're talking about is light dust and sawdust, right? So
Some of
Chances
the
are-
machines have chips like the planers and the joiners, but regardless, they're not gonna get in that slot. And if they do, they'll be pushed out. And the disadvantage of having twice as length of slider is mounting it on some of the machines.
Yeah, and
And
it'll
also
stick
you can
out,
see
like,
the
if we
button
just
getting
put a
fed.
longer one of these, it would stick out here and could bump into things.
Yeah.
Yeah.
How easy is this thing to disassemble? Because the one that failed at the shop failed closed. So it took the machine, took the equipment out of commission until I could disassemble the automated blast gate and then operate it manually. So is there like a quick and easy way, if this thing fails closed, to remove the actuator just from moving the gate itself and then just operate it manually until something can be.
It
There's
looks
two
like
screws
you
right
remove
here.
Those two screws.
These
You
two
remove
screws.
those-
Okay.
Yeah,
Oh.
remove those two screws.
Yeah.
Possibly
So one of them
slide.
goes into the gate itself, or to the gate housing. The other one has a nut on the back.
Wouldn't you have to also remove the assembly where it ties into the plate?
The yoke.
No,
There you go.
because once you take this off, you just lift the whole actuator off
Oh, that's right. Okay.
and the yoke just lifts right out. Yeah,
Okay.
you know, initially when I did this, this was a hole or a slot and closed. And then I looked at that and said, hey, I can make that better. There's a few other things, you know, that I improved initially. I had that, you know, this is a nice strong little extension around there, but it's a pain to install and remove. So the new one looks like this. I made it a little beefier, but
Oh, we
It's
can't see.
open.
We're still on the animation. Can we show your see your camera?
Yeah,
sure.
Tim, on where you have the that U bracket attached to the gate,
Yep,
you have those screws going in, right?
yep,
Now, if those screws were on a handle that had pins or something that could just be opened up and pulled out, then that whole gate and the U piece would just be able to be slid manually back and forth, right? If you could just pull those screws out, see those two screws that you have on the sides
yep,
right there, and
yep.
on the opposite side.
That's true.
Instead of using screws, use something that flexed and just pulled in, because there's, because then you could just pull those out and then manually move it.
Yeah, that's
Love this
good. They
pin.
could be like some kind of a spring pin, but that's another thing too. You could just
Yeah,
undo these two screws, leave the actuator in place. If you undo these two screws, this would slide back and forth.
yeah.
Yeah,
That could be just thumb screws.
yeah, they could be thumb screws. That's
Could
true.
be thumb screws. Yep.
Well, you guys are expecting lots of failures.
We just think of everything, try and think of everything. One of the things I love about, you know,
Paul-
I've done a lot of design on my own, and then things just don't occur to you. And you go in front of a group and someone goes, why didn't you think of that? And you go, because I'm stupid. So it's always good to have a group. Many heads are better than one. And one of the things I like about this group is a lot of creative people. And so I welcome the input.
And Dave, Paul's been doing a lot of the maintenance on equipment at the shop, so that's his point of view. It's like, okay, what happens when it breaks? How do I make it work again without having to get into the whole thing?
Yeah, the one that failed was on one of the saw stops, so it basically took a critical component of the shop out of service until it could be disassembled. And of course, it was kind of like hands off because this is a beta thing. So it was out of commission until I could go in there and take it apart. So I'm just thinking of, a shop supervisor. We don't want to, if we can operate it manually, that's preferred. Second choice after failure, and just make it easy enough for a supervisor to convert it to a manual operation temporarily.
Yeah, so the easiest way here, I guess, would be to remove these two screws. If they were thumb screws, it makes them easy to remove. And also, if they're thumb screws, we might not over torque it because this is 3D resin at the moment. Now, I might change that and just use I think my little baby router could actually make one of these out of a thick piece of acrylic. The problem is that it's not all 3-axis accessible. Everything's 3-axis almost, except these holes would have to be drilled in after the fact. But that's quite doable. And
Can I
one
ask
thing
a question about
Sure.
how you'd envision the Arduino being involved in this or integrated into this design?
Well, Dallas answered that with his idea.
Well, that's just what we would use to monitor and control is what we'd be using it. It's just it's just a controller. That's one of the prime uses of an Arduino. But we would monitor the current to the linear actuator. So if we go over current, we know there's a stall and we could stop it. But we can also then use it for diagnostics and for machine information.
So the Arduino would listen for a switch closure or something like that, and then start the linear actuator closing.
So
or-
you
or
put an AC current
Current loop.
measuring loop on it, and you measure. This will tell you how much current's going through the AC. Luckily, these are all AC pieces of AC equipment. So the easiest thing is you get in there and put this on one of the lines.
The linear actuator is AC?
No, you're talking about, so the Arduino will control the linear actuator, which is DC. So there'll be a little DC power supply.
Okay,
and
okay,
stuff.
okay. Yeah,
But
sensing
in
the
order
current
to
for the equipment
monitor-
and then causing the actuator to open or close.
Yeah.
Yeah. So there's two
You can
sensing
also monitor
operations.
that
One is,
current for the machine.
one is sensing to tell when the piece of machinery is turned on and thereby turn on the actuator. The other is to monitor the motor inside the actuator itself to protect it.
And how would that monitoring be done? Do you know?
This
The
monitoring would be
monitor-
done simply by a current monitor. So you could use either a small Hall effect, or it's a low enough current, you could just use a standard, well, you could run it across a small shunt resistor and look at the voltage on it.
Oh, okay. As I understand it on the Arduino, there is a analog to digital converter already
Yeah.
built in, right?
Yep.
So you could hook that to the resistor and then measure the voltage and so forth.
Exactly. Yep.
Okay.
Yeah, I mean, there's lots. The basic operation using Arduino, I think, would be quite simple. I haven't done a lot with Arduino myself, so I'm not volunteering to do it. But you know, you have a programmable device there that you can add a whole lot of additional information data that you could pull off of it.
Yeah, in the chat, there's the modern devices. It's a little current sensor that contact less. So you just wrap it around a power cord and it will detect current flow, and then you just monitor analog inputs on the Arduino. So that would be one way of sensing the AC current. The DC current of the actuator is another thing. So it'd have to kind of like do a
Yeah, the same kind of loop that Doug just showed. Like I have one here on this is a Hall effect pickup that I'm about to install on my electrified 1935 Chevy pickup truck. They're simple approach for monitoring current.
When are you going to bring that over to shop for show and tell? Maybe
The
next
shop's
eye
open.
opener.
I did bring it by the other week there, but nobody was around.
Maybe when
I
we
was
have
just
our
dropping
next
off
first
wood.
eye opener.
I will bring it by. I promise I will.
Cool. I'm looking forward to seeing that.
Um,
You know, I think there's a ton of things we can do with the Arduino. We can take it to all types of levels, but we know we can do just basic control. We're doing that right now, even without the Arduino, just using a current switch. The mechanics is what's been vexing us because we just keep burning out the linear actuators.
yeah, I'm interested to try this. I haven't tested it under load. I haven't tested under vacuum. I think maybe Jerry and I will get a chance to do that Thursday. And I've just kind of been playing and fine tuning the design and learning a few things about it.
So what holds the linear actuator to the gate?
Okay, so
Those two screws there, those 3 screws?
so the linear actuator here, let me, what did I isolate?
I'm just thinking if there was some sort of shear pin. Just for
There is
quick,
no shear pin. The problem is the forces we're talking about are fairly low. And better than a shear pin would be a fuse, and better than a fuse
Okay.
would be an Arduino with a little smarts. I mean, it could stop, back up, and try again. For example, a shear pin or a fuse is going to become a maintenance item. It's going to take the thing down. Someone's going to have to go fix it.
well, I was just thinking how long it's going to take to get the Arduino and all that stuff going. Whereas if we had something quick that would basically just still protect, so you're not blowing up these things.
The fuse will do that in a heartbeat, though. just
Yeah,
for-
the fuse would work for that for temporary.
Yeah. Okay. Then yeah, we'll throw that in there. Measure what the
Yeah.
current is, and then throw it in there.
So I used my 3D printer for 2 different parts in this design. One is I needed a standoff here for the actuator. So I just basically made a custom notched washer effectively. And in fact, on the other side here, there's a piece of the aluminum housing that's proud, and here sticks up. So there's a recess inside the standoff to accommodate that. So that's a 3D part. And then of course, this right here is a 3D printed part. And for those of you who aren't familiar with how that works in Fusion 360, you find the component that you want to export an STL, save as XTL, and it goes out to an STL, and you can use whatever slicer you're comfortable using. Since I use a resin printer, I have to use an external slicer, and I use one called Chitu Box, and it works great. Specialized piece of equipment, but there is in the manufacturing option the ability to do FDM slicing and to generate the code and directly drive the 3D printer from Fusion 360.
You can actually do it a lot faster if you just send it directly to the 3D printer too, rather than doing the export.
Yeah,
That's much faster than the,
so that's what you're doing now, Dallas?
yes.
So let's see how we do that. So let's,
If you just go over to your menu at the top over here, the second one, yeah, no up, just stay in your design.
okay,
Second one from the left there, it's a drop down. Keep going left. No, up at the top. You were just about there. Right next to the save. Next one. What's it? That file. Yeah, the file menu. Drop there. Go to the
file
file.
menu. Yeah.
Yeah, then go to 3D print.
Oh, wow.
You click on that. You pick your part, and it goes straight out. You don't have to do any export.
Oh, wow. Okay. So send to 3D print utility, find your print utility.
Or you can send it to a file if you don't send it to a utility.
Right. Cool. Yeah, I'm not using FDM, so I'm not as familiar with it. Refinement options, output.
It's much faster.
Huh.
Do you use Octoprint, Dallas?
Yes, I do.
So yeah, back when we first started talking about this, so over a year ago, one of the objectives was to try and use, find a tool that can do a bunch of different things for us and have fewer design tools. So really, now that I learned how to do this, I don't really think I need V-carve for much other than maybe perhaps doing some of those fancy inlays that I had fun doing in V-carve. I still need Lightburn for doing the laser stuff. And, but a 3D printer you can do from here, CNC you can generate from here. The resin printer I can't, but there's a lot we can do. And the great thing about the community is there's a bunch of things people here like Lem and Dallas are doing that I'm not doing yet with it, and that other people aren't doing. So there, we learn from the group. You have questions.
Will you share your file with us?
Sure. I will. I'll make a copy of this so that somebody messes with it. I keep one that's
Yeah, that's a good idea.
my original, but because Fusion is cloud-based, it's basically a link that I share.
Right.
So I'll put the share link in the discussion group in the forum.
So by doing this yoke in this way, I'm not understanding quite the physics of this. Why is there not a twisting motion there? Why is there not a?
Well, so the.
Oh, I see where the pin's at now. I didn't get where it was sitting before.
Yeah, so this is free to rotate here, so it can't put a twist on the carriage, and the axis of these pins
It's right in the center.
passes right through the lead
I got
screw.
it.
So it's
I
not
see how
twisting
that
there either. And
I
then
thought that
this
was-
has freedom so that this can the yoke can adjust as it needs to.
Ah, got it.
So
You know,
that's
if you-
assuming that twisting moments, bending moments on the carriage are a potential problem. If they are, this eliminates them. If
you
they're
look
not,
at
it
the
still
other
eliminates
end,
them.
if you look at the mount on the other end, typically these things are mounted. See where that mounting hole is you have there?
Yeah.
Usually this thing is turned 90 degrees. And that has a loose screw in there. I can't point at yeah, but normally that whole mechanism is rotated 90 degrees. And
Well-
that thing can move on that screw right there.
On a
So
linear
that end-
actuator, they're usually 90 degrees to that.
So it rotates, so it can pivot on that, at least in
Well-
that one direction. So that's what you'll see on things. Because usually when you're pushing, there's going to be a rotation of something that you're rotating as you're moving. Normally it's not just a straight in and out. It's like some sort of, like a door.
Yeah.
Right.
So there's this rotation going on, and that's why that mount at that end has that screw and is that way. So normally that would be mounted so that that can move freely.
This is in the hardware kit.
Yeah, that's probably so, right. That probably goes at that end. So
But
that
that's
can-
also so you can screw into something this way and then connect the actuator on here. I gotta find that other.
Yeah,
Where did I put that other actuator I had? Oh, right here. So I have a piece of an actuator here that Jerry gave me that has the lead screw removed, so we can move the carriage and see how it would slide back and forth. And here's where we found that if it had twist on it, we got a lot more friction. Now the lead screw in there is going to help keep it straighter to some extent, but that was an idea. And then this would typically go on here with a pin so that there's some freedom for something that is acting, like you say, like a door actuator or something like that that's rotating.
yeah.
Well, that's the other question though in our design. If the gate that was done by the fellow up in Orange County had basically it rotated I think I'm trying to recall how that was. It rotated like a disc, didn't it?
It was a servo motor, and
That's right,
whether,
he had a servo motor on there.
yeah, it's a servo motor on there, and then so it had an arm with a pin in a slot, basically. The challenge with that is you need a fair amount of torque on that servo.
Right.
And as Jerry pointed out, I don't think that Larry was, so Larry's automation was first open the gate, then turn on the vac system.
It's a single person shop.
Yes. And then turn off the vac and then close the gate. So he wasn't moving the gate under load.
Hmm.
And that makes a significant difference.
And there's also side lobe on that because all the force isn't in the correct direction. A lot of it's tangential, so that would push the slider against the sides of the track, which is why he used one that was twice as long as Doug was talking about, the long ones, to keep the slider in line. That was the thing that kept it in line.
Yeah, the proper slot design, I mean, the orientation of that slot, how that slot's designed would go a long ways as well. But yeah, I mean, I don't think that we were that far out before. I think that going with the yoke design here and taking away any of the twisting on the carriage is part of it. And after looking at the what was happening in here, I think that the going with this rounded surface on the gate, this front rounded surface on the gate is actually going to help avoid the risk of jamming. And then, as others pointed out, beveling these edges a little bit.
Now you just have to figure out a cover for it to keep it dust free.
Well, that was the other thing. We talked about the dust free, and I'm looking at it. Let me show everything again. And I don't have a good way to dust proof this in a dusty environment. I've done a lot of IP67 design to make things dust and waterproof, and it's a real pain. And those were fairly small things. Sometimes when you try to enclose something to protect it and you're not quite good enough, instead what you do is you entrap it. It's particularly true with water. If you try and hold water out and you don't do a good enough job, it becomes a water container and it ends up holding the water in. And so my thought so far is that I think the best approach is to leave it fairly open. Maybe once in a while, give it a blast with some compressed air, but have the Arduino monitoring so that if something jams in here or here, between these, that the peak current monitoring protects the motor.
So it has to use the
Dust
full,
tolerant rather than dust proof.
so it's required, you have to use the full throw, it looks like that, huh?
You do, yeah. So
Pretty much.
the way it works is inside here. I don't think you'll be able to see it, but inside, oh yeah, a little bit. Inside there is a set of contacts. It's like a capped on circuit, flex circuit. And there are sliding contacts like brushes on the inside of this carriage. And when it hits the end and changes the circuit, it breaks the circuit so it doesn't go any further.
We could use external limit switches, but the ones that are built into the actuator are clear at the end of the throw.
So basically,
you got a 5-inch gate. You got a 5-inch gate, and you have 5 inches of throw. So there really can't be anything stuck at the end of those.
Well, it's in this design. So basically, this is designed to go all the way here to all the way here.
We
So
could
if
use a
there's any-
longer, we can use a longer actuator. Right now, we're using 100 millimeters, so we're only using 4 inches. And that's, but you could use 125 millimeter ones and then put limit switches on there to get it precise.
Right.
Put our own switches on, yeah.
Yeah.
Yeah, I mean, either fully open or fully extended or fully retracted. Anything in between will burn motors if something gets
Jammed.
burn the motors up if anything impedes its movement.
But that's true. If we used a longer one and limit switches, we could avoid that as well.
Well, you don't need limit switches if you have an Arduino, but the next size up in this is 200 millimeters.
Yeah, that's a bit much.
Yeah, but that's only in that, from that company. There's other manufacturers too.
Not affordable like that and that quality that I found. I looked hard and long.
You know, having worked on a lot of embedded devices, I'd have to say that when you add Arduino to the mix, you just give yourself so much capability. I'm a mechie, not an electrical guy, but you know, adding processing power just opens up a lot of possibility. There's things we haven't thought of yet. We'll do this and someone will have a bright idea and we'll just spin the code and add a sensor and away we go.
Yeah, the problem with the relays is you're always applying 12 volts to that actuator. With an Arduino with an H bridge, you can shut it off after a certain amount of time and you never burn out the motor. Need somebody to do the Arduino design now.
Well, Tim said spin the code so easily that he's got to have some knowledge.
That's management speak. That's not doer.
I wouldn't mind working on the Arduino code if you need somebody to work on it.
We do, Lim.
Yeah, I'm a coder. 40 years of coding work. So it's,
Well, there you go.
I haven't done any in a while. So it'd be nice to kind of dust off the cobwebs and do something again.
Yeah, no,
I have-
I'd love to work with you on that. We're still, I want to get this mechanical part down so that we can go forward with it. But the Arduino really is what's going to make this thing even much more effective for us.
Yeah, I have one or two here at home. I'll break it out and hook it up with the IDE and start playing around with it, just so I'll be ready to start working whenever you tell me to.
Okay.
Cool.
Yeah, you probably want to figure out how you're going to get your data out of it. Once you figure that out, you might figure out that the Arduino doesn't work. You'll want something that has wireless capability so that it can send the data over Wi-Fi to the PC in the office or something.
Or an XP over to to a Pi.
Right. Yeah.
Well,
So
we
yeah,
would-
one of the whole reasons for the Arduino is basically to also keep track of the maintenance, how much, what's going on with the machines, their usage and stuff.
Well, we would have to run wires to every blast gate or power them locally at every blast gate. So it's, there's got to be some thought put to this as far as, how we do interface. And, wireless is, powered locally, then raises some issues, whereas if you just run like Cat 3 or Cat 5 to each blast gate location, then you can power it from a central location, monitor it from a central location, and run limit switches if we go in that mode. So it just get out a big piece of napkin.
Yeah, that's another whole design discussion there, the architecture, how you do it.
Yeah.
But it's like designing this mechanically. There's a million different approaches we could take.
keep in
Yeah.
mind though, is the actuators that we have require 12 volts, a little less than an amp. So thinking is run 24 volts to them with a little regulator so that you can use small wire from a central power supply or something like that. But like Dallas said, there's a lot of ways to do it. And then it makes sense to have wireless to get the data out, and online onboard data storage in non-volatile memory, and Wi-Fi or Bluetooth to get it to a central processor that can monitor things and stuff like that.
Yeah, I just posted a link to the Raspberry Pi Zero W.
I just looked at that.
It's only $10 and it has Wi-Fi built in.
Yeah, I haven't played with that yet. I've seen they're out, but I haven't played with one.
Yeah, it's
Yeah, I mean,
just
the
that
other-
you generally don't have a whole lot of Linux people around, except for me. How many of you guys run Linux? Oh, okay,
Work.
good. We got two of
I
us.
could spell it.
A lot of my career was in programming Unix and Linux and so forth.
Awesome.
So David, all we need is a couple analog channels, one to monitor the current to the machine, and one to monitor the current to the actuator. Maybe a timer to record duty cycles and time on, time off, maybe power monitoring, that sort of thing. Does that Raspberry do that?
I
It's
think it
pretty
has that
powerful.
capability.
Yeah, I don't think the Raspberry Pi has a very good A to D, but you can get them for like $5. I mean, you can get an A to D that you can use.
We don't
add
need
to
a
it.
very good A to D, like an 8-bit's probably fine.
Yeah, they just don't have. I don't think the Pi has an A to D on it. Not that I recall.
They're available in lots of interfaces too, like SPIs and all that, whatever the Raspberry takes. It's just somebody.
Oh yeah. There's
Somebody needs
enough,
to do the design, I guess.
right. There's enough I/O there. And the other thing that's good, what I have a Raspberry Pi Zero W on my hydroponics garden. Basically, it's controlling through MQTT messages, the light switch, and the water pump. Yeah, Lem,
Are you growing any raspberries in your hydroponic garden?
that's right.
I'm sure you are.
Not raspberries.
Yeah, pot's legal now, so.
That's right. Yeah, so when I mentioned MQTT, that's one of the common protocols for IoT stuff, for home automation type stuff. There's lots of software to get those messages back, and that's kind of what you might, messaging system that this might go ahead and send out for machine maintenance and stuff like that.
So just as a rollout, once we get the mechanical piece of this thing ready to go, we do have what do we have, 9 of these, Jerry?
Yep.
We have 9 of the linear actuators already in hand that the manufacturers provided us for prototypes. They gave us a big discount. So we could do 9 gates right now with that, and then while we're developing the Arduino or whatever we're going to use for our control board. We put those.
So what do you think, Lem, an H bridge?
A huge difference for us.
Just use an H bridge, like what is it, the 298, I think, or LM 298 or something.
Yeah, there's some like hats that you can get for the Mega or the Uno versions of the Arduino for Wi-Fi. If that's what you're referring to.
No, it's H bridge is a DC control. It's for motor control for forward and reverse.
Okay.
So you're going to want to control the motion back and forth. That's what an H bridge would be, the thing that the Raspberry Pi or the Arduino would control the H bridge, which then controls the high power motor movement.
So guys, what would you think about getting we'll get the prototypes done, get the mechanical part working. Maybe we get a little subgroup going talking about the control system to go with this. We do a similar session like this just to talk about what the architecture would be and make some basic choices and begin to test out a few different ideas for this. I know a couple other people in the shop that I
Good
think
idea. Yeah.
able to contribute.
Yeah, I like it.
Okay.
Hey guys, I just I'm new to this. I don't know the history of what you guys are talking about here. I've been listening all night. I have a question that maybe is a stupid question, but if you get, is there a reason you guys aren't using like a pneumatic actuator versus this mechanical motor type actuator?
You would need pneumatics at every machine.
Yeah, but you got to run the, yeah, you got to run, you know, controller electricity for all this other stuff you're talking about. Yeah, you would need, but you would just need a little air supply.
Yeah, we still need to be able to control the others, but pneumatics is an option. That is a choice.
I mean, it would
pneumatic actuators could be done.
It seems like it would simplify it because you wouldn't have to worry about burning out the motor that's moving the thing in and out.
That's true.
You're adding the whole. So I mean, at least if it didn't work, it would maybe be easier to override manually somehow or something instead.
Yeah, from what I just saw, so earlier when Tim was doing some stuff about exporting G-code, exporting stuff out of Fusion, which I don't do. So I was just like, while he was doing that, I was kind of searching for DIY blast gates, and I saw the one with the servo motor and the wire and stuff, and I saw one with the pneumatics, little pneumatics. The link to all the parts. It's about $15 for the pneumatic solenoid, $15 for the pneumatic pump or whatever you call it there, the actuator, like actuator. And let's see, it was like $15 for the gate, but you get the gate, so it was like $30 then you could get that. And it was, yeah, so it would be $30 to go pneumatic, plus a bunch of line.
Yeah, but the line you can run with PEX now.
Yeah, it's 1/4-inch line.
Yeah,
just
just
little tiny things.
Yeah. Reason I like 6 months ago, I watched a YouTube video on a guy who did this in his shop, and he did it with a pneumatic actuator. So I just searched and found it. And I was looking at it again. He was actually getting his dust.
Is that black guy that does that?
Yeah, Jeremy Fielding.
Yeah,
So
he's a kick.
he actually also had his entire dust collection system turn on every time he turned on one of his machines.
That's the way my machines, my system.
You wouldn't need to do that. You just need the actuator.
Yeah.
So it's the same mechanical design. Maybe that's, I didn't understand what the problem was with why we redesigned the thing that goes in and out. It's getting stuck or something, I assume. But that would be the same. You would just use simplify the actuator instead of having like a motor and moving parts in a dust environment. It just seems like it might be.
Well, it actually might be a real good question to ask is for us just to do a little test on it. It wouldn't take much to have the compressed air there. Wouldn't take much.
No, it didn't look like a lot of parts. You know, you get a relay and the little valve that pushes the air back and forth. I don't know.
Yeah, that's what it was. It was just the solenoid, and the solenoid could go basically both ways.
Yeah.
And the actuator. And then
I don't want to throw a wrench into a plan you guys had going here with all this other data collection. I don't really understand what the other stuff you're trying to collect about the machine is, but
well, it's just like, you know, any machine that you run, you keep track of hours of use and stuff. So that was what it was spun to, that if we're going to go ahead and have this thing here, we can put on this other thing that's not only controlling it, but also monitoring the machine usage.
I'd like to have that for a couple of reasons. One of the things is not only maintenance of these machines, but yeah, we've got a floor space is a premium at the shop. And you have, do we really need all 3 bandsaws, for instance? Do we need 2 drill presses? If I knew how much those things were actually being run,
I see.
sometimes they're run concurrent with another machine.
Yeah.
That's another question.
Yeah.
That hollow chisel mortiser, you got to wipe the dust off that thing to use it, but it sits over there.
Yeah.
So that's all useful metrics to have too.
Yeah, no, definitely.
And we can't really have a product design without having some scope creep, right?
That's exactly right.
We used to call it galloping elegance.
Galloping elegance.
I don't know, I might be a little simplistic, but to me, the pneumatic thing is a lot more complicated than it needs to be, because you have electrical and pneumatics, and you solve the whole problem with pneumatics. I mean, with electrical, the fuses will protect the motors. I think we can probably do a good enough job with dust proofing the thing. So I'm kind of at a loss. And if we're monitoring things with the Arduino, we can see when things are degrading, if too much dust is getting in there, and service it at the time. So
yeah, Tom's point is you don't need to do any of that though. If you got something that's so powerful as you have with the pneumatic. No.
Just a thought.
No, I think it's an interesting option. We should, sometimes you got to take a step back and say, yeah, all these problems we're solving deserve some far away.
Sometimes you get pretty far down one avenue, you got to back up and check out a different street.
In the meantime, we're just about at the end of this street, and it seems I want to see if it works.
Yeah, I think we're close, and
got-
the changes I made are pretty minor, but I think they might address some issues. And there's been some good feedback tonight. Really appreciate that. I think we got a chance to maybe kick off this other group to look at controls. Thursday, I think Jerry and I are going to do some testing on this latest version of the design in the shop and see if we learn anything from that. And it's pretty straightforward to take it to the next step and just add it to all of them. It's a couple 3D printed parts and some laser cut acrylic and some fasteners, and away we go.
Yep.
I think we pretty much wrapped this up, and we're running short on time unless somebody has something pressing yet. The one thing I would like to say is I'm always looking for ideas on subjects for the design SIG. If people have questions, issues, suggestions, there's people out there that are doing things the rest of us aren't. And if someone who does a lot of 3D printing or a lot of CNC routing and uses Fusion 360 or one of the other design packages wants to lead a session, I'd greatly welcome that. Otherwise, feel free to throw questions out to the group or to myself and suggestions for how to make this SIG. It's our SIG, and everyone's part of it. And suggestions to make it more meaningful to you are welcome.
It could be interesting to have a maybe a session on doing double-sided machining. Basically, when since we're limited to 3 axes, to flip it over and machine it from 2 sides to get another dimension there, kind of.
Is that something you could lead?
Video.
Oh,
the guy who does the slicer that does CNC and laser and 3D
Oh, yeah, yeah.
printing. The Kerimoto
Yeah.
guy showed, I mean, just some really cool ways you take a 3D model, put it in, set up your CNC, and it, couple clicks, it sets pins for you, and then you basically flip it over, click the next one. It can be simple, and it supports VCarve or Shapeoko and most of the machines you guys have.
Yeah, there's some neat stuff there. That's a good subject though, Lem. Because with the I didn't do very much of it, but on the fruit bowl I did it, and I just used corner pins.
Corner pins, okay.
And what I did in that case was I took the corner pins, I made holes for the. Let me think about this. I guess the first side I did using the tape and glue. And then the second side, while I was doing the first side, I made 4 tooling holes in the corners and took them right down into the spoil board. Then I flipped it over. I used tape and glue again, but I used dowel pins in those 4 tooling holes in the corners to do the alignment and get the other side. But that was a symmetrical design. So yeah, I like that subject. I'm going to make a note of that and try and see what I can pick up on that and see if I can come up with some useful stuff for the group.
That'd be great. Yeah, I personally haven't done it, but I'd be interested in learning more how to do it because it seems to come out fairly often that to make a part, you can't do it just from 3 sides. You have to flip it over at some point. Yeah,
and the Kerimoto stuff that Doug was talking about, he showed that to me some time ago. It was really kind of innovative how he did it. And I'd also like, you know, if I do a part like we were talking about here, where'd the big one go? Like this part here, you know, I would need to machine from five sides to make this one. So that's something I had to play around with some of those ideas. Cool, good suggestion, Lem.
Yeah, and Carbide 3D actually makes something they call the flip jig, which is sort of makes it easy for their, they mainly make it for the Nomad, but you can use it on the larger Shapeoko too if you need to. But it's just for small parts. It doesn't cover anything large.
Mm-hmm. Cool.
I posted a video link in the chat. That is a video of a guy doing a pneumatic glass gate.
Oh, cool.
Something to look at.
Yeah, we could add some of these to the forum as well. I'm just going to capture them.
That'd be good. I may make a prototype of one of those just to take a look.
It might be just swapping out, you know, the motor, you know, system and the mount and the little mount, you know, for prototyping and stuff.
Yeah.
I mean, the gate looks pretty close to what you already have. What I see. So the size of this thing is very similar to the linear actuator.
Yeah, linear actuators are fairly robust and nice simple devices.
Yeah, I think that the thing about the linear actuators, you get the screw.
Yeah.
You got the screw.
I meant pneumatic actuators are pretty robust. Yeah.
Yeah. It's just they'll leak on you. That's about it. Yeah.
Cool. Okie doke. Well, thanks everybody for your time and your input. It was a great discussion and lots of good feedback, lots of good ideas. Always a great brainstorming session with this crowd. Storm of brains, some kind. And everybody have a good evening and a good month. We'll see
Hey,
some
Tim,
of
I
you
want to
soon.
say to you how much I appreciate you leading this effort. This really is interesting forum, but it's
Yeah.
I've learned so much in this last year that you've been doing this.
No, I'm glad it's been helpful. It's
Yeah.
been good for me too. I mean, we've all needed things to get us through this damn pandemic. So this at least gave me something.
Yeah. Well, thank you.
All right, thanks very much.
Thanks, guys.
Yeah.
Good night, everybody.
Thanks.
talk.
Ciao.
Ciao.
Mm.
Bye.